first day of algebra. Today we will be learning about factoring quadratic formulas. To start, let us take attendance. Courtney Tackett.
Like here.
So now that we're all here, a quadratic is a form of a polynomial. It takes the form, stop texting and pay
Excuse
attention.
me?
Math is important. A quadratic takes the form of ax squared plus bx plus c. The a, b, and c values stand for numerical constants. Now, aren't you anxious to learn how to factor?
No.
Yes! Alrighty, let's get started. First problem we will be looking at today is x squared plus 6x plus 5. The first thing to know about factoring quadratics is you must use MAM, always. This stands for multiply, add, multiply. This is what you use to find the factor of the quadratic. First, you must start out with the first variable. Now, this one says multiply. So what multiplies to x squared? Courtney?
Me?
Yes. I know you know this.
No. X and X?
Yes, very good. So, in each parenthetical bubble, we put an x, because x times x adds to x squared. Now, to find the second term in each parenthetical, we must use the add and multiply sections of MAM. Now, what two numbers add to 6 and multiply to 5? Courtney?
I guess like 1 and 5?
Correct!
I actually got it.
Now, to determine the sign for these, you look at the signs of this. Now, the 6x is positive, which means numbers must add to a positive number. And the 5 is positive, which means they must multiply to be a positive number. Therefore, both signs shall be addition.
What if the 6 was negative?
If the 6 was negative, you would find the factors that add up to -6 and multiply to 5. Then, you would most likely have a negative in both of these, because a negative times a negative is a positive.
Ah.
So, the factor of x squared plus 6x plus 5 is x plus 1 times x plus 5.
Math is still stupid.
The rules of MAM still apply even though an x may not be a variable in the equation. For example,
That's not the same letter.
y squared plus 9y plus 8 can be factored. Would you like to try, Courtney?
I guess.
Here you are.
So it needs to add to 9
Yes.
and multiply to 8.
Correct.
So would that be like 2 and 4 is 6, right?
Yes.
Alright.
That's completely irrelevant, though.
Well, I was thinking 2 and 4 multiply to 8. Like, what else
No,
multiplies?
the same numbers need to add to 9 and multiply to 8. You must not use two separate sets of numbers.
Okay. So would it be 1 and 8?
Correct.
Really?
Very well done.
Math is still stupid.
Now take a seat. Now, the best way to learn is through repetition, so we shall do more math problems.
I don't want to.
The next problem is a squared plus 9a plus 20. Now, once again, it does not matter if there's an a, a q, a z, or a p, you factor quadratics the same way. So, to start this out, a squared, what multiplies to it?
A and A.
Correct, a and a. Now, what adds to 9 and multiplies to 20?
2 and 10 is 12. 4 and 5.
Correct. What sign should go in these parentheses?
Wait, I know this. Division isn't a sign, right?
No, division is not an option in this case. It must either be positive or negative.
Positive.
Positive, correct. Now, there are instances when a quadratic may not be evenly factored. For instance, n squared minus 12n minus 35. Now, class, let's attempt to factor. We start out with the value of n. What multiplies to 35 and adds to 12?
5 and 7.
Incorrect. There are no numbers in this instance which will add to negative 12 and multiply to negative 35.
But I don't understand because 5 and 7 multiply to 35 last time I checked.
But they don't add to negative 12.
But they add to 12.
But a negative 7 plus a negative 5 may equal a negative 12. But when you multiply them, it would give you a positive 35.
Oh,
So,
okay.
if this was a positive 35, you would be correct. However, since it is not, this cannot be factored. This would be known as a prime number. Now, class, I have placed some quadratics on the board. A few of them are not factorable and a few of them are. I would like you to tell me which ones are which. First, let us begin. Plus 4p plus 5.
Okay. P squared would be, oh no, would be P and P. Okay. But then, it's not factorable.
Correct. P squared plus 4p plus 5 is not factorable. Next, x squared minus 9x plus 20 is a factorable.
Okay, let me see. X and X. And then it would be a 4 and a 5. And they'd both be negative, so it's factorable.
Correct. It is factorable. The factors of x squared minus 9x plus 20 are x minus 4 and x minus 5. The last equation, s squared plus 2s minus 35. Coordinate.
S and S. Like, is that right?
That is correct. The two factors of s squared plus 2s minus 35 are s plus 7 and s minus 5. Therefore, the first equation was not factorable, while the following two are.
This is actually kind of interesting.
Thank you. Another way of factoring when you may not be sure if it is factorable at all is using the quadratic formula. This wonderful equation allows you to find the factors of a thing with barely using any brain power. Now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. To remind this, you can use the Happy Little Ice Cream Man song. X equals negative b plus or minus the square root of b squared minus 4c all over 2a. So,
Quite like that one.
let us try some equations now using the quadratic formula to solve them. As you will remember from the beginning, the form of a quadratic is ax squared plus bx plus c. Now, these values are 1, negative 11, and 30 in this case, because the quadratic is r squared minus 11r plus 30. Always be sure to include the sign in front of the term. For example, using 11 instead of negative 11 as the value of b may mess up your calculations. Ensure that the negative is included. To begin, it is recommended that you create a key of all your values that you will need during the equation. This ensures that there is less chance of a mistake. What is the value of negative b in this instance, Courtney?
11?
Correct, because b is equal to negative 11, therefore negative b is simply 11.
Do I get a gold star?
Yes. What is the value of b squared?
121.
Correct, because negative 11 squared is 121. What would be the value of 4ac?
120, right?
Correct.
These numbers are big.
To find 4ac, you multiply 1 times 30 times 4, 120. What is the value of 2a?
You said A is 1, right?
A is 1 because there is simply an r squared. The coefficient of r squared is 1.
So 2.
2 is correct.
I think I'm starting to get this math thing.
So now that we have all the variables written out in our key, let's plug them into the formula.
Let's.
Do we remember our formula?
Okay.
X equals,
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
very good.
That thing is catchy.
Quite so.
I feel like I'm never gonna forget it.
Come to the nerd side, we have cookies. Now, let's plug in our values. Negative b, 11, plus or minus the square root of 121 minus 120, all over 2.
Okay,
Now.
so
When we compute this, what do we get, Courtney?
when you compute it, okay, 121 minus 120 is 1. So the
Correct.
square root of that is just 1.
Correct.
Okay, so it's going to be 11 plus 1 over 2. And then 11 minus 1 over 2? Right?
Yes. Because when you have the plus or minus sign, you must ensure that you do 11 plus 1 over 2 and 11 minus 1 over 2. This will give you both of your roots for the equation. In this case, 11 plus 1 over 2 comes out to
6.
6. And 11 minus 1 over 2 comes out to
5.
correct.
So
And
those
this-
are the two answers?
Yes.
It's
In
that
this case,
easy?
5 and 6 are the factors of r squared minus 11r plus 30. It's that easy. Tell you that the quadratic formula gives you the same answer as factoring by hand, we shall try that equation again. If you were to mam r squared minus 11r plus 30, you would first start out with an r, Then, what multiplies to 30 and adds to 11?
6 and 5.
Correct. What are the signs in this equation?
They'd both be negative.
Correct. Now, when you solve this equation using MAM, you get r minus 6 and r minus 5. This is the same answer we got before, because if you were to set r minus 6 or r minus 5 equal to 0, you would get 6 and 5 respectively. Those are the roots, and that is what we solve for using the quadratic formula.
Okay, I think that kind of makes sense. What? How am I supposed to do this one?
Quadratic factoring problems may not always come in the simple form ax squared plus bx plus c. Sometimes there are multiple x's. In this instance, it is 2x to the 6th minus 8x to the 5th minus 42x to the 4th. Now, we can get rid of these ugly variables by factoring before we factor. What do all of these terms have in common?
2x to the 4th.
Correct. When we take 2x to the 4th out of the equation, we are going to divide each term in the equation by 2x to the 4th, giving us x squared minus 4x minus 21. Now, this is looking more like a quadratic. Can you solve the quadratic?
I can try. And thanks to your help, I can.
You can succeed in anything.
I can't put the cap on though. That would be x and x. And would that be negative 7 plus 3?
Correct.
What happens to this?
The 2x to the 4th would drop down in front of the other two factors, making this factor 2x to the 4th times x minus 7 times x plus 3.
Well, that's
Very
a
well
lot
done.
easier than I thought.
Exactly. Let us try another. Our next problem is 3r cubed minus 30r squared plus 72r. Now, from what we have learned, what is our first step?
You factor before you factor.
Correct. Now, what goes into every single one of these terms?
3r.
That's correct again. When we divide each term by 3r, what are we left with?
R squared minus 10r plus 24.
Correct. Now, simply factor the quadratic inside the parentheses. What do you get?
R minus 6 and r minus 4?
Correct. And do not forget to drop down the term in front,
Right.
3r. So your final factor will be 3r times r minus 6 times r minus 4.
How do I solve for the roots, or whatever you call them then?
To solve for the roots, we tea time. In which you set every single multiplication term equal to 0. For example, in the case of 3r times r minus 6 times r minus 4, we would set 3r equal to 0, and then solve for r, getting r equals 0.
I get it.
For the next, r minus 6 equals to 0. So add over the 6, r equals 6. And r minus 4 equals 0. R equals 4.
This one
Therefore,
isn't too hard.
our three roots would be r equals 0, r equals 6, and r equals 4. However, you only solve for a root if the original given problem is set equal to 0. Otherwise, it is not an equation and you cannot find its roots. Simply factor.
Understood.
She said I don't spend time like